Okay, so we are now looking at restricted Bernoulli trials. This is the probability that some event will occur on the nth trial. Okay, remember the 4 properties of Bernoulli's. You have to have n number of trials. They each have to be independent of each other. You have to have 2 outcomes, success and failure, and the probability of success would have to be the same for each trial. That makes it a Bernoulli. Okay, so let's say our example is as follows. A fair 6-sided dice is thrown repeatedly until a 6 will appear for the 3rd time. Find the probability that this would take exactly 15 throws of the dice and give your answer to the nearest percentage. So I want a 6 to come up for the 3rd time on the 15th throw. Okay, so the probability that 6 will appear for the 3rd time on the 15th throw of that dice. So if 6 is only coming up for the 3rd time, by the time I have thrown the dice 15 times, that means on the previous 14 throws of the dice, I've obviously already gotten 2 6s. Okay? So on the previous 14 throws of that dice, 2 6s appeared. And on the 15th throw of the dice, the 3rd 6 came up. So I already know what is happening on the 15th throw. Okay, a 6 will come up on the 15th throw. The probability of getting a 6 when you throw a dice is 1/6. And means multiply. This is the Bernoulli trial part. Okay, so I will be using that formula. So on the previous 14 throws of the dice, so there are 14 trials, so that's 14. And 2 6s have already come up. So R is your probability of, R is your success amount. So I want 6 to come up twice. So that's 14, choose 2. The probability of success, P, is going to be 1/6 to the power of R, which is 2. Probability of failure, Q, that means not getting a 6. If you don't get a 6 on a dice, you get any of the other 5 numbers. That's 5 6 to the power of N minus R. 14 take away 2, that's 12. So you can then plug all of that into your calculator, all right, and that will eventually give me back 0.04725, and the question did say to give your answer to the nearest percentage, so I'm going to multiply it by 100 first, so bring your decimal 2 places to the right, and that will give me 4.725, and then I'm going to round that to the nearest percentage, which is approximately 5%. So 5% of the time, the probability that you would land on a 6 for the 3rd time when you throw a dice, the probability you land on a 6 for the 3rd time on the 15th throw would be 5%. Okay, so that's a restricted Bernoulli because we already know what's happening on the 15th throw. It's what happened on the previous 14 throws that then you concern yourself with. So that's the first example. Okay, the next example. A coin is flipped repeatedly until 10 heads appears. Find the probability that this will take exactly 17 flips of the coin and give your answer to 3 decimal places. Okay, so 10 I want heads to come up 10 times, and I want it to appear for the 10th time on the 17th flip of the coin. That means on the previous 16 flips of that coin, heads must have obviously already come up 9 times. If it's coming up for the 10th time on the 17th flip. Okay, so I'm going to put down that information. So it's the probability that heads will appear for the 10th time on the 17th flip. So I already know what's happening on the 17th flip. I'm getting heads. Okay, so heads comes up on the 17th flip. Probability of getting heads is 1/2. And means you're multiplying. So what happened then on the previous 16 flips? Well, if heads has already come up for the 10th time on the 17th flip, on the previous 16 flips, heads must have come up 9 times. Okay, so you want heads to be successful 9 times. So the number of trials is 16, so that's 16, choose 9. The probability of success, well, the probability of getting heads is 1/2. So that's 1/2 to the power of R, which is 9. You want heads to come up 9 times. Failure will be that you don't get heads, so that's tails. Probability of getting tails is 1/2 to the power of N minus R, so 16 take away 9 is 7. So you're now going to plug all of that into your calculator and multiply it by 1/2 afterwards. Okay, and that gives you that decimal, and the question did say give your answer to 3 decimal places. So 3 decimal places, I look at the 4th digit after the decimal point, so your answer is approximately 0.087. So the probability that you will land on heads for the 10th time on the 17th flip of the coin is 0.087. Okay, the next example then. This isn't a restricted Bernoulli trial now, this is just a regular Bernoulli trial. So the driver pass rate in a test centre is 1/2. So the probability you pass is a half. Obviously the probability that you fail is another half. Each trial is independent of each other. Okay, each driver is obviously independent. So we've got two independent events. You're either passing the test or not passing the test. The probability of passing is the same for each trial, and we have n amount of trials. N people will take that driving test. So I actually don't know the value for n, right? So you can leave n as n. The probability that 2 or less people pass the test. So 2 or less people. That means 2 people can pass the test, 1 person could pass the test, or no people pass the test. It can be written as this expression, where a, b, and c are all natural numbers. Okay, find the values of a, b, and c. So I need to work out the probability that 2 or less people will pass the test, and it is a Bernoulli trial. And I should be able to manipulate those probabilities so that it can be written like this. Okay, and once I have it written in that format, I will then be able to solve for a, b, and c. So I'm going to set that up. So the probability that 2 or less people pass the test means no people pass the test, 1 person passes the test, or 2 people pass the test. And I'm going to set up my Bernoulli trial for that. Remember, P is the probability that you do pass the test, so that's your success rate, which is a half. Therefore, the probability that you don't pass is the other half. Okay? And there are n amount of trials, so n is just going to be n, because we don't know what that is. Okay, so that's the probability that none will pass the test. An or plus or, so this could be another scenario, so that's or, and or means plus. This could be your scenario. We just don't know what n is each time. Or it could have been that 2 people passed the test. I'm going to start breaking these down, okay? Now remember, n choose 0. Like if you wanted it, like you obviously can't put n into your calculator, but you could pick any random number. Like what would 5 choose 0 be? And it will be 1. But there's a formula in the log tables for n choose or, which is n factorial all over or factorial by n minus or factorial. So to get out n choose 1 and n choose 2, you're going to apply this rule. Okay, so I'm going to do each of these out individually to show you how we're working them out, because it eventually has to look like this. That's an algebraic expression. As it stands, we're in the binomial distribution for Bernoulli trials. So I need to work out the 3 of these, which is the probability of none, 1, or 2. Okay? Right, so the probability of none was n choose 0. And again, if you apply that formula of n factorial all over or factorial by n minus or factorial, you will eventually get out 1. Or like you could throw into your calculator, any number choose 0. Like 5 choose 0 is 1. 20 choose 0 is going to be a 1. But to use your formula, right, that would be n factorial all over or factorial, so that's 0 factorial, by n minus or factorial. So that's n factorial up on top. On the bottom then you have 0 factorial, that's 1. 1 multiplied by n minus 0, that's just n factorial. The n factorials divide into each other once, so they're gone, you're left with 1. Alright, so that's 1. A half to the power of 0 is 1. And then a half to the power of n minus 0 is a half to the power of n. Rules of indices, right? 1 by 1 doesn't change anything, and multiplied by a half to the power of n is still going to be a half to the power of n. And then a half to the power of n means that's 1 to the power of n, which is just 1, and 2 to the power of n, which is 2 to the power of n. So I have simplified the probability of none is equivalent to 1 all over 2 to the power of n. So it's in index format, right? So I'm going to be using that. Or it could have been the probability of 1 happening, and or means plus. Okay, so I will be adding that answer onto my next answer. So it was n choose 1 by a half to the power of 1 by a half to the power of n minus 1. N choose 1, if we use that rule, okay, in the log tables, n choose or. N factorial all over or factorial by n minus or factorial. So n factorial will be the same as, just write out as far as you need to write until you can see something that's common underneath. So that'll be n by n minus 1 by n minus 2 by n minus 3 and so on. But I'm going to stop here with the factorial symbol. All over. 1 factorial is just 1. N minus 1 factorial. I'm not going to write it all out because automatically I can see that n minus 1 factorial will divide into the bottom and it will divide into the top. So you're then just left with n multiplied by 1, which is n. Okay, so n choose 1 worked out to be n. And on the calculator, if you typed in, like 8 choose 1 is 8, 20 choose 1 is 20, 45 choose 1 would be 45. So n choose 1 is n. Okay, so that's n multiplied by a half to the power of 1 is a half to the power of n minus or, so n minus 1. So that means that's going to be 1 to the power of n minus 1, which is just 1, and then 2 to the power of n minus 1. So it'll end up looking like this. So it was n multiplied by a half, multiplied by a half to the power of n minus 1 will become 1 over n to the power of n, 2 to the power of n minus 1. Then top by top by top, all over bottom by bottom. So n by 1 is n. 2 multiplied by 2 to the power of n minus 1. So remember, that's a 2 to the power of 1. Rules of indices, you can add the two powers. So it'll be 1 plus n minus 1. The ones will cancel each other out, and you're actually just left with 2 to the power of n. So the probability of 1 occurring simplifies down to n all over 2 to the power of n. So I'll be using that as well. So I now have, this was the probability that none occurred, plus this is the probability that 1 occurred, and then lastly, the probability of 2 occurring. So that's going to be n choose 2. Again, use your formula to work that out. Because this time you actually couldn't plug it into the calculator to say, you know, what's 5 choose 2, because it's very different for every single one, right? So you use your formula again. So it'll be n factorial all over r factorial by n minus r factorial. So n factorial, I'm just going to write out a couple of terms, okay, until I don't need to write any more. So it'll be n by n minus 1, by n minus 2, by n minus 3, by n minus 4, but I'll stop at n minus 2 and I'll put in the factorial symbol, because underneath you had 2 factorial, which is just 2 by 1, that's 2. And n minus 2 factorial, I'm leaving it as it is because automatically I can see that the two of those will divide into each other. And then you are just left with n by n minus 1 multiplied by 1, which is n by n minus 1, all over 2 multiplied by 1, which is 2. So I have now written the probability of 2 times occurring is equal to this expression. Okay? Sorry. The probability of 2 occurring is not that answer. It's n choose 2 is that answer, right? So that's that. So I'm now subbing that back into the rest of it. So that becomes n by n minus 1 over 2. A half to the power of 2 is going to be 1 squared all over 2 squared. So that's just 1. 1 squared is 1 all over 2 to the power of 2. And I'm leaving it as 2 to the power of 2. I'm not writing it as 4 because I want them all to be in powers of 2. And then a half to the power of n minus 2. That means 1 is to the power of n minus 2, which is just 1. And 2 to the power of n minus 2, which is 2 to the power of n minus 2. Top by top by top, all over bottom by bottom by bottom. So n by n minus 1 by 1 by 1 is n by n minus 1. And then all over. That's 2 to the power of 1. So 2 to the power of 1 multiplied by 2 to the power of 2 multiplied by 2 to the power of n minus 2. You're just going to add all the indices. So that's going to be 1 plus 2, which is 3. 3 plus n minus 2, which eventually will become 2 to the power of n minus 1. Okay, so the probability of 2 occurring can now be written as this algebraic expression. Okay, so the 3 things that I have now circled, so this was the probability of none occurring, or 1 might have occurred, or 2 might have occurred. So I'm going to be adding those 3 circled expressions, and it'll look like this. Okay, so I eventually want to get that expression, I want it to look like this. So I want to write it as one single fraction. So I'm going to draw my common denominator line. Now, the lowest common denominator, or lowest common multiple between those 3 terms is going to be 2 to the power of n minus, or n plus 1. Because basically, trapped inside in 2 to the power of n plus 1, there already is a 2 to the power of n. Like if you were to split those up, right, that is the same as 2 to the power of n by 2 to the power of 1. Okay? So obviously that's a 2 to the power of n, that's a 2 to the power of n, and that's 2 times 2 to the power of n. So the lowest common multiple is going to be 2 to the power of n minus 1, or you can write that as 2 times 2 to the power of n. So then when you're dividing it in, 2 to the power of n will divide into that bottom, cover over the one you're talking about, you'll be left with a 2. So then it's 2 multiplied by what's on top, which is a 1, so that's just 2. 2 to the power of n divides into that bottom, again cover over the one you're talking about, you're left with a 2. And then it's 2 multiplied by what's up on top, which is an n. Plus 2 to the power of n minus 1 divides into 2 to the power of n minus 1. It goes in once, multiplied by what's up on top, which is n, a bracket, n minus 1. Okay, so that's where I'm at now. I just need to tidy that up a little bit further to get it looking like this. So look, in the denominator, I already have 2 to the power of n minus 1. I need to get the top looking like a quadratic. So my denominator is fine. I just need to work with this. So multiply out those brackets, and you'll get this expression. Then just tidy it up. So n squared, 2n minus 1n, that's 1n, plus 2, and it's all over 2 to the power of n plus 1. Okay, so I now have it in the format they wanted it to be in. So they wanted it to be in the format of an squared plus bn plus c all over 2 to the power of n plus 1. And the question had originally asked to find the values of a, b, and c. That means a must be 1, b must be 1, and c must be 2. Right, so a equals 1, b is equal to 1, and c must be equal to 2. Okay, and that's that one finished.